Hello student, welcome back to lecture series on correlation and regression, which is from the statistic. Already I have started lecture series based on the correlation and regression. So within that we are learning only the correlation right now. So if you want to see similar videos guys, go in, check in my I button or description box. You will get the complete playlist for a previous video for correlation also you will get it there, okay? Yes, so in our today's video guys, I'm gonna explain to you all one of the special method called Pearson coefficient of correlation, which is very much important guys. Definitely you will get the question in your SPPU question paper, okay? Using Pearson coefficient method you have to find out the correlation, okay? Yes, so without further ado, let's get dive into our today's lecture. I'm gonna explain to you all the method first, okay? First of all, we go understanding the formulas and methods. These are the very much important, okay? Yes, so Pearson coefficient method. So what is actually meaning of a Pearson coefficient method and what it needed, okay? What it needed to develop this method, okay? So the use of this method to measure intensity or degree of a relationship between variables, okay? What we needed to measure intensity or degree okay, of linear relation between variable of linear relationship, okay, of linear relationship between variables, okay, between two variables, okay? Pearson coefficient method, what it says that to measure intensity or degree of a linear relationship between two variables, okay? So whenever we have two different variables, if you want the intensity or degree of their linear relationship, okay, so we use the Pearson coefficient method, okay? Yes, so Pearson developed the method formula, okay? Pearson developed the formula for relation coefficient, okay? That is very much important, relation coefficient, okay? Okay, let me write the formula, okay? A relationship, okay? Correlation between two variable x and y, okay? Let me write correlation between two variables, okay? Consider that x and y, correlation between two variable x and y we denote, okay, denoted or designated as, okay, denoted as r of xy, okay? R of xy denoted as a correlation between two variable xy, okay? And the formula it is written as, okay, r of xy, it is written as, you already learned this in your previous standard guys, okay? R of xy equal to covariance of xy, okay? Covariance of xy, that we denote COV, okay? Covariance of xy divided by sigma x and sigma y, okay? Sigma x means standard deviation with respect to variable x, standard deviation with respect to variable y. Covariance of xy means COV of xy means covariance of xy, okay? Yes, what is meant by COV of xy? COV of xy, we write it as the covariance of xy, covariance of xy, okay? And covariance of xy, we write covariance of xy as a summation of xi minus x bar, summation of xi minus x bar, yi minus y bar, okay? Summation of xi minus x bar and yi minus y bar divided by n, okay? This one is the formula for covariance of xy, okay? and x bar, it is you all are familiar here. X bar is the arithmetic mean. Okay, x bar is arithmetic mean, comma y bar also are arithmetic mean. Okay, x bar and y bar, it denote as the arithmetic mean. Okay, this one is easier guys, not the difficult. It is way easier for finding the covariance of xy. Okay, so x bar y bar is the arithmetic mean. Okay, yes, x bar y bar is arithmetic and x bar y bar arithmetic means, and xi and yi are given data set, and number of data set how many times occurred, that represent small n. Okay, small n represent number of data set, occurrence of number of data sets. Okay, so we can write this one also. Here we can see guys, covariance of xy can be written as using these two formulas. Okay, 1 upon n summation of xi yi minus x bar y bar. Okay, bracket complete. And covariance of xy, it can be written as 1 upon n, that means summation of xi yi divided by n minus summation of xi divided by n summation of yi divided by n. Okay, we can take any one of the formula for finding the covariance. Okay, yes, so for finding covariance, now let's go to the formula. What we have given in our formula over here, covariance of xy divided by sigma x sigma y. Okay, so you understood here the meaning of a covariance of xy, so you can replace the formula over here. Now we want the sigma x and sigma y, which is a standard deviation with respect to x and standard deviation with respect to y, that you already learned in my previous lecture guys. Okay, it is way easier. Okay, we know that the sigma x can be written as under square root of, okay, sigma x can be written as under square root of a summation of xi square divided by small n minus summation of xi divided by n bracket square. Okay, square root complete. This is a formula already we learned here in our previous class. We applied this formula for our example guys. Okay, so there is one more formula for sigma x. We also can write this one as summation of xi. Okay, summation of xi square divided by n. Okay, summation of xi square divided by n minus x bar. Okay, x bar square divided by n. Okay, this is the formula that you can apply for, use it for your finding the standard deviation. Okay, for with respect to variable x. Okay, with respect to variable x, it is way easier guys, not the difficult. And if you have variable y, formula it will remain same. Okay, so if you want the standard deviation for the table y, need to replace x by y only. Okay, for example, if you want standard deviation with respect to y, so how can you write the formula? Under square root we consider summation of yi bracket square divided by n minus summation of yi divided by n bracket square under square root. Okay, these are the formula guys we needed here for finding the answer. Okay, now see that we have left here with the one more method of a step deviation that we already learned in our previous class. Okay, previous lecture. So it is way easier guys, not the difficult. Okay, so if you want, I will explain to you all that the method of a step deviation.